Hey guys, so today we're talking about solubility curves. So as you can see, here is a big graph. And on the y-axis, we have grams of solute per 100 grams of water. So what that means is we're putting different solutes, so different substances in our solvent of water, and it's going to be 100 grams of water. So how much of our solute did we put into 100 grams of water? And then at the x-axis, you're going to see our temperature in degrees Celsius. So it goes from 0 to 100 degrees Celsius. So the reason that we are stuck at 0 and 100 is because water will freeze at 0 and water will boil at 100 degrees Celsius. So that's why we have this range down here. And as you can see, there's several different lines. They each have a different color, and the chemical symbol is also in that respective color. So here we see potassium iodide, and we see this line here. It's kind of like an orangish color. And then we see like even sodium nitrate. We see this red color. And then we also see some things go down. And we're going to talk about these a little bit. So for example, let's just focus on KNO3, this big blue line here, this like light blue line, KNO3, potassium nitrate. So at 60 degrees Celsius here, we're going to go up this line, up, and it meets the line, the blue line, at approximately 106 grams, maybe 107 grams. That means that 107 grams of potassium nitrate can dissolve in 100 grams of water at 60 degrees Celsius. And this would be the point of saturation, and we're going to talk about that in a moment. Let's say instead of 107, if let's say we only put 90 grams in, 100 grams of water at 60 degrees Celsius, and we're talking about KNO3, then it would be unsaturated, meaning we could still add more of our KNO3 to that water to saturate it. So we had unsaturated it if we only put 90 grams in. Let's say we put 120 grams in. I put 120 grams of potassium nitrate and 100 grams of water at 60 degrees Celsius. That's still saturated, but now I'm going to have solute or precipitate at the bottom. I'm going to have some of that KNO3 go to the bottom of, let's say, our beaker or our test tube. All right, so we have a saturated solution with some excess left over at the bottom. All right, so that's looking at this a little bit. So going here, so our solubility curves, again, so solubility curves measures the amount of solute that's able to dissolve in a solvent at given temperatures. Solubility is the maximum amount of our solute that can be dissolved. It's our saturated point. So the maximum amount that of our substance that we can dissolve is our saturation point. So that's that point on that line. And it's measured of grams solute per grams of 100 grams of our solvent, which would be our water. Just talks a little bit about the word dissolving. So dissolving occurs at the surface of, let's say, table salt, NaCl, so at the surface of those particles. And we can affect the rate by either crushing it, stirring it, heating it up. So we can speed up the rate that it dissolves, but we can't speed up the fact that, hey, we have some extra at the bottom and it's already saturated. Just stirring it's not going to allow it to dissolve. You're just stirring it. So we cannot affect how much can dissolve, but we can affect how fast it can dissolve. All right. Temperature affects the solubility. So of solids, we saw those lines that went up. Those are our ionic compounds. They went up. They're solid states trying to be dissolved in our water as our solvent. So as we increase the temperature, we actually increase the solubility of our solids. So that's why those lines increased. So we typically do our laundry in hot water or warm water so that, let's say we use the solid substance, maybe you use borax, I don't know, whatever you use, and it dissolves those particles. Then we have our gases. Gases, if let's say our solute is a gas, it's going to be less soluble as the temperature increases. So we saw those lines that went down. Those lines that went down, they started up here and then they decreased as we increased the temperature. So think of your soda pop that you're drinking. Let's say you have a can of Coca-Cola, you open it up at room temperature versus you opening it up in, let's say, from the refrigerator, you're going to have a different taste, and it's because of how much of our carbon dioxide is dissolved at that point. So it tastes a little bit funny maybe at room temperature because you're not going to have as much of that fizz and those particles like, touching your nose because it's less soluble at higher temperatures, my bad. All right, so we see here that trend of our gases. All right, so pressure will also affect it. Gases are less soluble at lower pressures because we have less particles pushing it down, so they're easier to escape, all right? We open that can of our soda, we allow some of that undissolved CO2 to escape. Like dissolves like, so if it's a polar solvent, it will dissolve polar solute. If it is a nonpolar solvent, it will dissolve nonpolar solutes. Again, stirring and grinding up only affects the rate at which it dissolves. Here we have our terms saturated, unsaturated, and supersaturated. So again, saturated is the maximum amount of our solute that we can dissolve at a given temperature. So at that point on our line, that is how much we can dissolve at that temperature. Unsaturated means that we have less of our solute that we can dissolve compared to our saturated piece. And supersaturated is typically not going to occur for what we're doing in here. But that means that more solute is dissolved than we can actually dissolve it at saturated point. That's an unstable situation. It may release solute suddenly, so you might see like precipitate immediately at the bottom. This, again, does not typically occur. So you're not going to see that on our graph unless I were to say all of it dissolved. All right, so these terms, we have miscible and immiscible. Miscible is the fact that things can mix. So, for example, we have like maybe isopropyl alcohol, and we have water. They will mix. Either one of them can be our solute. Either one can be the solvent. And then immiscible means that it's not going to mix at all. Maybe like, for example, we have oil and water. So here we have a question that's an example. So using our solubility chart, determine how much potassium nitrate can dissolve in 100 grams of water at 40 degrees Celsius. So how I tackle this is I say, all right, so this graph is already in 100 grams of water, so that's good. But we're looking at 40 degrees Celsius, and we're looking at KNO3. So we find 40 degrees Celsius, temperatures on our x-axis, and we're going to go up the line until we find KNO3. KNO3 is this red line here. So where we have 40 and that red line meeting is approximately 67 grams. So 67 grams of KNO3 can dissolve in 100 grams of water at 40 degrees Celsius. That would be the point of saturation. All right, first question. If solute has been added to a solvent so that no more will dissolve, the solution is called saturated. A saturated solution of sugar and water is heated. What will happen to the amount of sugar that could dissolve? So sugar, solid particle, we put it in water, we're heating it up. What's going to happen is it's going to increase the solubility. So we can add more sugar particles at a higher temperature, which will affect the amount of solute that dissolves. So which is going to affect the amount, not the rate. So we have stirring, crushing, or grinding, or heating the mixture. Remember how much can dissolve is going to be affected by heating up our mixture. And then I think this is our last question. So what will happen to the solubility of carbon dioxide? Carbon dioxide is a gas. If a glass of carbonated beverage is allowed to warm. So we increase the temperature. We're talking about a gas dissolved in something. So what's going to happen is it's going to be less soluble. Therefore, our carbon dioxide will escape if it has the chance, maybe the lid's open. All right, there you have it. I hope you learned a little bit of something, maybe especially reading that solubility curve graph. And there are questions shared with you via Google Classroom to answer. Thank you.